Welcome back. Today we're talking about properties of exponents. Now, exponents, when you are simplifying an expression that has lots of stuff going on, you're just going to have to look at it piece by piece. And there are some exponent rules that we can use, but I want to kind of come up with those so you understand where they're coming from. Now, a student I had a few years back, her and her mom came up with this mnemonic device, MADSIM, to help us remember those rules. So let's go ahead and prove what they came up with. So this acronym is saying when we multiply, we add our exponents. Now notice up in our toolbox, we have base and exponent. So exponents, that little script at the very top, if you've got it attached to a number or a variable. And the base is what the term or number that the exponent is attached to. So it's easier if we just look at this with an example. So I'm going to make up a multiplying example. I'm just going to pick a number, let's say 3. So 3 to the 5th times 3, we'll do 3 cubed, okay? 3 to the 5th times 3 cubed. Now, notice both of these have a base of 3. That's what's going to allow us to use our exponent rule, so that's the most important thing. They must have the same base. Now, so they're telling us that 3 to the 5th times 3 cubed equals, we're going to keep our base and simply add the exponents. 5 plus 3 is 3 to the 8th. Okay, let's see if that really works. Well, let's think about what is 3 to the 5th. So 3 to the 5th is 5 3s. So 3 times 3 times 3 times 3 times 3. It's totally storming outside. I'm sorry if you guys can hear that. So I have 5 3s. So, and then we are going to multiply it by 3 cubed. So, didn't switch colors. 3 cubed, so 3 more 3s. So let's look at this. That's a lot of 3s. If I don't have a calculator, I don't want to do 3 times 3 times, no, just no. So I don't want to do that, but I can simplify it. How many 3s are there? 1, 2, 3, 4, 5, 6, 7. OMG, there are 8. 3 to the 8th. So that is where that exponent rule comes from. If you are multiplying and they have the same base, you can simply add the exponents. Cool? So let's prove the next one. The next one tells us that if we are dividing, we, you guessed it, subtract the exponents. Kind of makes sense when you're dividing. Stuff gets smaller. So I'm going to take let's use a variable this time. So let's say x. So I've got x to the 8th divided by x to the 4th. Trying to use numbers I didn't use yet. Why am I torturing myself? X to the 8th, that's 8 x's. Okay, well first, it tells us when we're dividing, we subtract. So 8 minus 4, we should end up with x to the 4th. Let's prove it. So x to the 8th, we've got 8 x's. Oh, 3, 6, 7, 8. Okay, so I've got 8 x's in the numerator and 4 x's in the denominator. What's anything divided by itself? What's 5 divided by 5? 1. So x divided by x, 1. So I'm going to go ahead and cancel out 4 of those x's. So what are we left with? 4 x's. Oh man, I was really lame and stayed all with the same color that time. It's all right, I'll make up for it later. So we just proved when dividing, as long as we have the same base, we can subtract our exponent. So keep the base, subtract the exponent. So x to the 4th, we are left with 4 x's. If you can remember these rules, do you see how that's a huge time saver so you don't have to write out all of this stuff? for sure. But again, if you forget or you're kind of second guessing yourself, just write it out. Okay? It's better to be safe than sorry. All right, so let's do another one. Let's see. Jolene, my puppy Jolene is sitting next to me. I mean, she's not a puppy, she's 10, but she's next to me. So we're going to use a J. So let's see, J to the third, and we're going to raise it to the fifth power. So J to the third to the fifth power. All right, so, well, let's look at this piece by piece. Oh, sorry, I probably should have talked about what that rule is. So what this is saying is if we have an exponent raised to an exponent, or a power to a power, we are going to, you guessed it, multiply. Because think about how much faster something is growing if it's a power raised to another power. Like, it's growing exponentially. So another way to think about this, J to the third to the fifth, is saying we have 5 groups of J to the third, or 5 groups of 3 J's. J times J times J. There's one group. J times J times J. There's another group. You see how this can get a little tedious if you don't remember your rules. What's that, 4? All right, one more. So how many J's did we end up with? 3, 6, 9, 12, 15. So it equals J to the 15th. Fantastic. Wouldn't that have been so much easier to just say 3 times 5 is 15? For sure. But again, I just want to prove to you guys this is why. So they're not just taking these rules out of thin air. Somebody took a really long time and did a lot of math problems to say, hey, this actually works every time. Amazing. So it's there. So our mnemonic device is MADSIM. Oh, I tweaked this a little bit, so go ahead and ignore that. That's going to go with the next lesson. All right, so simplify the following. -4 r to the 4th, s to the -1, times -r to the -9. Ooh, that was a big lightning strike. To the -1st. Okay, so again, we are multiplying, which tells us that we add our exponents. However, we have a lot more going on here. So we are going to group things by base. So first, let's look at our, and I am going to use multiple colors here, so you can either use multiple colors, highlighter, whatever works for you. So I'm going to look at my coefficients. I have a -4 and a -r. How can we look at this to figure out a coefficient? What number could I put in here that wouldn't change it? A -1. So -4 times -1 gives us 4. Cool. All right, now let's look at our r's. We have r to the 4th times r to the -9th. Again, when multiplying, we add the exponents. So 4 and -9 gives us r to the, there's more negatives, so 9 minus 4 is 5, so -5. Okay? And now look at our s's. S to the -1, s to the -1, like bases of s, so we keep our base of s, add those exponents, -1 and -1 gives us -2. Now, you have simplified this, yes, however, right now, you are cursing at me. You are. We cannot leave expressions with negatives in the exponents. It is a very big math faux pas. We do not want to do that. Like, literally, somebody's going to look at that and be like, oh, you're yelling at me. So we've got to get rid of these negative exponents. All right. I could just tell you what to do, but I want to show you why we do it. I know I'm so annoying like that. Feel free to, fast forward, but maybe you'll actually remember it if you understand why. So let's come over here, and I'm just going to pick 5 because 5 is a nice, easy number for me. So what's 5 to the 1st? 5? You're a genius. All right. What's 5 squared? 5 times 5? 25? Man, you are on it. All right, one step up. What's 5 cubed? 25. 5 times 5 is 25 times 5 is 125. Beautiful. Okay. Awesome. Now, find the pattern. What? Yeah, I want you to look at this and find the pattern. What are we doing to get from 5 to 25 to 125? What's the common pattern here? Well, 5 times 5 is 25, times another 5 gives us 125. We are multiplying by 5. Sweet? So, with that thought in mind, I want to kind of work backwards because we're going to prove a couple different things here. So if we work backwards, what's 5 to the 0 power? Well, if we were multiplying, but we're working backwards, what are we going to do instead? Well, instead of multiplying, we're going to, you guessed it, divide. What's 5 divided by 5? 1. You just proved that 5 to the 0 is actually 1. It is not 0, it's 1. Any non-zero number to the 0 power is 1. You just proved it. Crazy. Now don't forget. All right, now let's go ahead and work on backwards because again, we got those nasty negative exponents and I am not okay with that. Me and the rest of the math community. So, if I work backwards, what's 5 to the negative 1? Well, again, we just said we're dividing by 5, so let's divide by 5. What's 1 divided by 5? 1/5. Oh my gosh. To get rid of that negative exponent, we're literally just going to flip it. Take the reciprocal, put it under 1. So if we were to continue this pattern, what's 5 to the negative 2? It would be, we're dividing by 5 again, so 1 over either 5 squared or, well, what's 5 squared? 25. Look at this. We start at this one, we go 5, 25, 125. If we work backwards, 1/5, 1/25. So what would the next one be? 1/125. Amazing. You guys are awesome. So anytime you have a negative exponent, to get rid of the negative exponent, you simply flip it. So if it's in the numerator, move her down to the denominator. If it's in the denominator, go ahead and bump it up to the numerator. So let's come back over here and let's fix this because again, I'm telling you, it's just making me cringe. It's yelling at me so bad. So 4. Is there anything wrong with our coefficient of 4? Nope, it's good. So we're going to keep it. So 4 stays in the numerator. All right. Now what about this r to the negative 5? No. Negative. Sorry, Charlie. You got to go. So right now it's in the numerator, so we are going to move it to the denominator and it becomes an r to the positive 5. All better. Same thing. Let's look at that s. S to the negative 2. You got to go, sir. So move it to the denominator. S squared. Now, everything has positive exponents. It's all beautiful. Box and flower. There's another YouTube guy that does box and flower, and it just makes me laugh, so I like it. Cool. All right, let's try another one. I probably won't have enough room down there, so I'm going to move. So negative 24, P24, whoa, P to the 20th, Q to the 12th, divided by 8, P to the 4th, Q to the 18th. Awesome. All right, so again, we're going to group. So let's look at our coefficients first. What's negative 24 divided by 8? Negative 3. Okay, and now we're going to look at our p's. P to the 20th divided by P to the 4th. So now coefficients, you just do the normal operation because it's just a number. Once you get to something that has an exponent, that's where we need our rules. So again, we said when dividing, Madsen tells us dividing, we subtract. So where are there more? This is how I do it. There is more than one way. So I look at, there's more in the numerator, so I'm going to do 20 minus 4, leaving P to the 16th, which is 16 P's left in the numerator. Are you following me? Okay, so now let's look at the Q's. So Q to the 12th divided by Q to the 18th. there's two ways you can subtract this. What I'm looking at is where are there more? So I'm looking, I say, hey, there's more q's in the denominator. So if I subtract this way, 18 minus 12, that leaves me with 6 q's where? In the denominator. If you did 12 minus 18, that's okay. You would get q to the negative 6. But again, what do you have to do when you get those negative exponents? You'd have to move it. So that's why from the beginning, I just look at where are there more. So exponents are all positive. We are simplified. All done. Fabulous. All right, let's try another. We have negative 3x to the 6th, y to the 4th, cubed. Now notice, what is being cubed? Everything in the parentheses. So we could literally write negative 3x to the 6th, y to the 4th times negative 3x to the 6th, y to the 4th times negative 3x to the 6th, y to the 4th, because there are 3 groups of them. Or I can just take that cube and apply it to all of the terms that are, well, to all of the pieces of the term that are in there. So that's, I'm going to look at this and I'm going to say, okay, well, what's negative 3 cubed? I'm starting with my coefficient like usual. So negative 3 cubed, negative 3 times 3. Nope, sorry, negative 3 cubed. So negative 3 times negative 3. Positive 9, good gracious, times a negative 3 gives me negative 27. I really did not want to forget that negative sign. So negative 3 times negative 3, positive 9 times negative 3, negative 27. All right, so what do we do when we have an exponent? Oh, different color, my bad. Exponent to an exponent, we multiply. So instead of writing out 3 glorious groups of x to the 6, I'm just simply going to say, what's 6 times 3? 18. Same thing for the y. Y to the 4th cubed. So that's 3 groups of 4, which gives me 4, 4, 4, 4, 8, 12. Y to the 12th. Just multiply. All of my exponents are beautiful and positive, so boom. I'm good, good. That's it. Oh, it's pretty short and sweet. I would like for you to try the next 2 and then go ahead and come back and check your work. So pause the video, try the next work, come back and check. Let's see how you do. All right, so I simplified so far and I kind of wanted to pause to see how you guys did. So remember, this is a negative 1 in front, so negative 1 times negative 1, positive 1 times negative 1, negative 1 times negative 1, positive 1. So we're just left with 1, and then I got m to the 12th, n to the 16th. Hopefully you got that. Now I threw something in extra, so I didn't want you to freak out. What I want you to look at is, when you have an operation of adding and subtracting, you've got to look at, are they like terms? And that's all about the exponents. So, sorry, the bases and the exponents. So we have 1 m to the 12th, n to the 16th, minus 8 m to the 12th, n to the 16th. Because these both have the same base and exponent, m to the 12th, n to the 16th, we can combine these two terms. Now, if this last one said m to the 12th, n to the 15th, no, we would not be able to combine them. You would literally stop right there. There's nothing else that you can do. But since we can combine them, we're going to go ahead and do that. So what happens when I take 8 away from 1? I'm left with 7 in the whole. So I've got negative 7 m to the 12th, n to the 16th. Because remember, those bases stay the same because that's our term. Our term is m to the 12th, n to the 16th. It just tells us that we have negative 7 of them this time. That's it. All right, go ahead and pause that video. Try the next one. Let's see how you did. So I went ahead. Now here we had a couple different things going on. We had an exponent out here that we had to take care of, and then we had to divide. So exponents come first. Think of PEMDAS. So we go ahead and distribute those exponents, and I came up with 36, a to the 6th, b to the 4th. Then when I went to do my division, 36 divided by 4 left me with 9. I had more a's in the numerator, so I subtracted that way. I had more b's in the denominator, so I subtracted from the bottom. I'm left off with 9a squared divided by b to the 7th. All exponents are positive. All good to go. All right, so hopefully you had some success there. You're going to have some independent practice on your own. But I do want to come back. It says, how do we simplify an expression with an exponent of 0? Well, again, what is anything to that 0 power? 1. So I have uploaded another video for you guys in case you need that. He's there for you. So you can go ahead and click on that on your own if you need it. Have a great day. I'll see you soon.